We're going to add some more theorems to the proofs justification section in the front of our notebook. So the first theorem is the right angles congruence theorem, and the name of this theorem essentially explains what it means. If you have two angles that are both right angles, they're going to be congruent to each other. So if angle 1 and angle 2 are right angles, then they should be congruent to each other. Then angle 1 should be congruent to angle 2. So if they're both right angles, they should be congruent, essentially. That's all that you do. It's pretty simple. If you know two angles are both right angles, then you can just jump ahead and say they're congruent to each other. The next two theorems are a little tricky. Basically, they're saying if two angles are complementary to the same angle, then those angles are also going to be congruent. So for example, if I told you angle 1 and angle 2 are complementary, and angle 1 and angle 3 are complementary. So I'm just going to assign a random measure to angle 1. So let's say angle 1 is 40 degrees. That means that angle 2 has to be 50 degrees because they have to add up to 90. So in my second equation, or second sort of scenario, angle 1 is still 40 degrees because it can't change its measure. And if angle 1 and angle 3 are complementary, then that means angle 3 is also, its measure is also going to have to be 50 degrees. So angle 1 and angle 2 are complementary. Angle 1 and angle 3 are complementary. That means these two angles are going to have to be congruent to each other. So by the congruent complements theorem, angle 2 should be congruent to angle 3. Because angle 2 is complementary to angle 1, and angle 3 is also complementary to angle 1. Okay, another iteration of the congruent complements theorem is you might see something like this. Angle 1 and angle 2 are complementary, angle 3 and angle 4 are complementary, and then I might give you something like angle 1 is congruent to angle 3. So let's say angle 1 is 40 degrees. If angle 1 and angle 3 are congruent, that means angle 3 is also 40 degrees. And if angle 1 and angle 2 are complementary, that means angle 2 would need to be 50 degrees. So they have to add up to 90 if they're complementary. Their measures have to add up to 90. And then if angle 3 was 40 degrees and angle 3 and angle 4 are complementary, that means angle 4 has a measure of 50 degrees. So since angle 1 and angle 2 are congruent, angle 1 and 2 are complementary, angle 3 and angle 4 are complementary, it ends up that angle 2 and angle 4 are congruent as well. So then I could say angle 2 is congruent to angle 4. So those are two different ways that you might use the congruent complements theorem. Look for a repetition, like look for two statements that talk about angles being complementary. If you see two statements in your proof that use the word complementary, that talk about different sets of angles being complementary, you're probably going to use congruent complements theorem. So the congruent supplements theorem is the exact same concept. It's just that they're supplementary instead of complementary. So for example, if I said angle 5 and angle 6 are supplementary, angle 5 and angle 7 are supplementary, then by the congruent supplements theorem, I can say that angle 6 and angle 7 have to be congruent. Or another iteration would be angle 5 and angle 6 are supplementary, angle 7 and angle 8 are supplementary. And then if I told you like angle 6 was congruent to angle 8, if 6 and 8 are congruent, then that would mean 5 and 7 were congruent by the congruent supplements theorem.